Okay, class, welcome back. Today we're going to finish up our lectures about gases with our gas stoichiometry problems. My objective for you today is that you would be able to solve volume to mass gas stoichiometry problems. In saying that, let's dive into this math-heavy lesson. Okay, today we're going to jump into some more math with gases. But before we can start working with gas stoichiometric problems, we must first understand the relationship between the mole ratio and the volume a gas occupies. If we take the chemical equation of the synthesis of gaseous water vapors, we would state 2H2 gas plus 2O2 gas yields 2H2O gas. If we were wanting the molar relationship, we would just look at the coefficients and say that for every 2 moles of hydrogen gas, it would take 1 mole of oxygen gas and produce 2 moles of water vapors. This should not be anything new to you. Here's where we get some new stuff and bring lessons together. Avogadro's law states that equal volumes of gases at the same temperature and pressure contain equal number of particles. Thus, equal number of moles once balanced out. With this assumption, we can assume that the amount of liters of a substance is equal to the mole relationship of that substance. So, going back to our equation, it would take 2 liters of hydrogen gas and 1 liter of oxygen gas to form 2 liters of water vapors. Understanding that concept will allow us to solve for the first type of gas stoichiometric problems we will see, and that is volume to volume problems. The basic outline for solving these problems is first we must provide a balanced equation for the stated problem. Then we must identify our volume relationship between what is given and our desired product. Finally, we must multiply our given over 1 by the volume relationship. Not bad, right? Okay, let's practice this. What volume of oxygen gas is needed to complete a combustion of 4.0 liters of propane gas, which is C3H8? Assume the pressure and temperature remains constant. Okay, my first step is to write a balanced equation for this combustion. That means I have a hydrocarbon plus oxygen, and it's going to yield a carbon dioxide and water. Once I balance this out, I get C3H8 gas plus 5O2 gas yields 3 CO2 gas plus 4 H2O gas. My next step is to identify my volumetric relationship or my volume ratio between what is given and what I want. To do this, I look at my coefficient. Through looking at my coefficients, I see that there is 1 mole of propane to 5 moles of oxygen. That easily can be converted to liters, so 1 liter of propane to 5 liters of oxygen. Now my final step is to multiply my given volume by the relationship that will give me my desired product. I'm given 4 liters of propane, so I'm wanting to first put that over 1. Now I can either multiply it by the relationship of 5 liters of oxygen over 1 liter of propane, or 1 liter of propane over 5 liters of oxygen. Because I am wanting the volume of oxygen, and I am given the volume of propane, I'm going to want liters of propane to cancel out. This means I need to use the relationship of 5 liters of oxygen over 1 liter of propane. Now all I have to do is multiply my tops and my bottoms and then divide my top by my bottom. And I get that there is 20 liters of oxygen needed to react with 4 liters of propane to completely combust. Okay, so now we've got the easy problems out of the way. Let's dive into some more tedious ones. Remember, our ideal gas law formula is PV equals nRT, where P is pressure, V is volume, N is the number of moles of our gas, and R is our ideal gas constant, which is 0.0821 liter atmospheres per mole Kelvin, and T is our temperature in Kelvin. With this next type of problem, we are going to have to combine our knowledge of stoichiometric relationships with our ideal gas law. Usually these types of problems will give you a specific gaseous volume and ask you to find another gaseous mass produced. So here's the basic framework for these volume to mass problems. Like our volume to volume problems, our first step is going to be balancing a chemical equation. Or next, we solve a volume to volume problem to find the volume of a substance that is needed to be produced. Our third step is to take our ideal gas law and rearrange it for moles. Then we plug our determined value in along with our known values to solve for moles. Once we solve for moles, we can multiply our moles by the formula mass of the substance over 1 mole to get our desired mass. Now, let's see a practice problem. Ammonia is synthesized from hydrogen and nitrogen. If 5 liters of nitrogen reacts completely with hydrogen at a pressure of 3 atmospheres and a temperature of 298 Kelvin, how much ammonia in grams is produced? Step 1, write a balanced equation. So this is a synthesis problem, so hydrogen and nitrogen are going to come together to form ammonia. So N2 plus H2 yields NH3. This isn't balanced, however, so I'm going to have to balance it. Once I do this, I get N2 gas plus 3H2 gas yields 2NH3 gas. Now step 2 is to solve a volume-volume problem for our desired unit. We are going to take our 5.0 liters of nitrogen and we're going to find how much ammonia is produced. So now I'm going to use my 5 liters of nitrogen over 1, then use my volumetric relationship of the coefficients of 2 liters of ammonia over 1 liter of nitrogen. Once I multiply and divide out, this gives me 10 liters of ammonia produced. Now I can go to step 3. Step 3 says we use our ideal gas law to figure out how many moles of ammonia is in my 10 liters of ammonia. So I rearrange my equation to get moles of ammonia. So the equation should read N equals PV over RT. Now I plug in my known values, so my problem gave me 3 atmospheres for my pressure and 298 degrees Kelvin for my temperature. I know R, that's my ideal gas constant, so 0.0821 liter atmospheres per Kelvin. And finally, we solved for our volume earlier in our volume-to-volume problem, so we have 10 liters of ammonia. Now all I have to do is plug this into my calculator and I get that there are 1.23 moles of ammonia in 10 liters of ammonia. My final step is to convert my moles to grams using my formula mass. So I'm going to put 1.23 moles of ammonia over 1 and multiply it by ammonia's formula mass, which is 17.04 grams of ammonia over 1 mole of ammonia. This gives me that there are 21 grams of ammonia produced from our 5 liters of nitrogen. Okay, that's enough math for this video. Hopefully you saw how ideal gas laws can be used to solve stoichiometric types of problems. Remember, if you have any problems with these videos, you can always go back, rewind, rewatch, whatever you need. And saying that, keep up the good work in the classroom, and see you next time.